Okay, so now I'm just going to explain the basics of Kubernetes architecture. So there is a lot to it, uh, how to control the volumes, how to control the networking. But again, those things are something you are better off doing it and learning it on demand. So I'll just give you enough information to get the corresponding code running. You can still run the code without having to know this, but then if you face any errors, you will be completely out of context. Okay, so now coming to the architecture, basically like two things mainly: master node, the cloud, and the worker node. Okay, so now you have the cloud provider, okay, who is creating these instances, right? So now let's break down the master node, right? It has these following components: Kubernetes controller manager, cloud controller manager, Kubernetes API server, HCD, and scheduler. Okay, now let's look at this one by one, right? So let's ignore cloud controller manager for now. Okay, so Kubernetes controller manager, it's like a manager of all controllers. Now there is like volume controller, route controller, and service controllers, like, so there is a controller manager for each one of them, right? Okay, so volume controller manager, route controller manager, and service controller manager, right? So that deals with the respective functionalities of volume, right? If how to attach a volume to a pod, right? So now when you are using Kubernetes, you can no longer talk in terms of external volumes at the container level, because if the work is allotted to a different worker node, then the volume mounted onto that particular container is useless. So you have to really talk about volumes at the pod level, not at the container level anymore, once you talk about container orchestration. Okay, so now HCD, what is HCD? For the time being, it's just like a key value store. So all your interactions that you do with kubectl will go to the Kubernetes API server, and then from API server it stores into HCD. Okay, now Kubernetes server has all the logic of authentication and authorization. Again, we don't have to worry about that now. When you do like kubectl in the home folder, the configurations are present. Okay, so let me just show you where the configuration are present. Okay, see, this is where the configurations are present. Okay, so config cache, HTTP cache. So now, okay, this is where all the configurations are present. So you can take a look at this. Because it has my credentials, I am not sharing it. Okay, so now Kube API server has some authentication and authorization plugins before you can write anything to the XCD. So if you can see here, Cube API server is the single point of entry, right? So it stores into the XCD, and then if anything needs to be communicated to the kubelet, you communicate through the Cube API server. Okay, so now this concludes the uh, Kubernetes master node, controller manager, HCD, and scheduler. Now eventually all the cloud specific functionalities are moved towards cloud controller manager. Before, the cloud specific functionality was all distributed across every place. Kubernetes controller manager also had cloud specific functionality. Kube API server also had cloud specific functionality, and kubelet also had cloud specific functionality. Now all those are moved from these individual components into cloud controller manager. So now what will happen is, like, Kubernetes controller manager relies on cloud controller manager for any cloud specific functionality, right? So before, kubelet was taking care of communicating to the cloud and then initializing the node, but now it initializes the node, but it leaves out a flag such that the node cannot be provisioned as a worker node till the cloud controller manager pitches in and provides the cloud specific functionality for the worker node. Okay, and then same thing with the Kube API server. So it added the cloud specific functionality. Now Kube API server waits for the cloud controller manager for any cloud specific functionality. Okay, so again I will go into details about the cloud controller manager. So cloud controller manager is the main reason why Kubernetes is cloud provider agnostic, but the rest of the things like AWS or anything, it's not cloud provider agnostic. The beanstalk format in which you talk to AWS, no other cloud provider can understand it. Okay, so now coming to the master node again, Kubernetes controller manager, HCD scheduler. Okay, so Kubernetes controller manager, you have the node controller for responding when the nodes go down, replication controller, uh, which is necessary for ensuring there is a sufficient number of replicas. Endpoint controller or like service controller, populates the endpoints object, and then the service account and token controllers, this for the API access. Okay, so now you have these components making up the master node. In our case, these are running on our machine. Okay, so when it comes to Minikube, it's not really running on the cloud. It's instead of cloud, it's a VM, single node Kubernetes cluster. When I say single node, single worker node Kubernetes cluster inside the Linux VM, which is provisioned by Minikube. Okay, so that is what is the the basics of the Kubernetes architecture. Okay, so now who has implemented the CCM, right? The following cloud providers has implemented the CCM. So once AWS implements CCM, pretty much all other cloud providers follow, and that's what is happening. Okay, so now we have the basic of the architecture. So now in the next 5-minute video I will talk about CCM and how it's important. Okay, just know the basics and anything about Docker networking or Docker volume. So those are also very important topics. Those things you can learn as and when the demand arises. Okay, and before you start relying excessively on volumes, one thing to keep in mind is like lot of the databases like MongoDB or Redis, there are some excellent platforms as service along with monitoring and backups available, and it is most of the times cheaper to use those than to you know provision your own volumes. Okay, again something to keep in mind, uh, but just like understand the overall architecture so that you can choose the right solution. See you in the next section.